This question is about electrolysis, and here we have the table in which we have an electrolyte and we have to nominate the anode and cathode material. For dilute aqueous potassium iodide, the result on anode will be oxygen and on cathode we have hydrogen. For aqueous copper sulfate, we have oxygen at anode and copper at cathode. And for molten lead iodide, we have lead at anode, and for cathode we have, for cathode we have lead, and for anode we have iodine released here. If you are using the different products in copper electrode are used. If you are using copper electrode instead of graphite electrode, then what will be the observation in that case? Electrolyte will stays blue because of the copper sulfate solution. Cathode gets coated with a pink solid, and your anode it gets smaller. Then the next question is, here is magnesium is manufactured by the electrolysis of molten magnesium chloride, and at anode we have chloride ions react to make chlorine molecule, and you have to construct the ionic half equation. So it's a simple Cl minus goes to form Cl2 chlorine molecule plus 2 electrons released. To balance this, we have 2 in the start, so 2 chloride ions in the start. Next question is oxides of nitrogen such as nitrogen monoxide. It's an atmospheric pollutant, and by volume it is 0.00200% is present in exhaust gases, and if 960 decimeter cube of exhaust gases is released, then what is the amount in number of molecules of that nitrogen monoxide? This equation, we done this numerical here. So here we have this. First of all, we have to convert the volume in the very first step, we have to calculate the volume of nitrogen monoxide in the exhaust gas. So it is 0.00200%. So it's divided by 100 into 960 to get the volume. Then you convert it into liter value, right? Volume, convert into volume. Then convert the volume of nitrogen into moles by using ideal conditions. So you divide the value with 24 decimeter cube, 24 liter here. So then calculate the number of molecules of nitrogen monoxide. That will be just multiply the number of moles into Avogadro's number. So you will get the answer, which is 4.82 into 10 is to the 20 molecules. So that is the answer here. Again, with the question, the next question here is nitrogen and oxygen react to make nitrogen monoxide inside a car engine. You have to construct the equation. It's simple. Nitrogen plus oxygen, N2 plus O2 goes from 2NO. One adverse effect of oxide of nitrogen as an air pollutant, it causes acidic rain. It is also photochemical smoke. It causes a lot of respiratory problems. So you can write any one. Describe how oxides of nitrogen formed in car engine and removed by a catalytic converter. It reacted with carbon monoxide to make nitrogen, and then it released. Then we have the rate of diffusion of nitrogen dioxide is less than of nitrogen monoxide. Explain why the rate of diffusion of nitrogen dioxide is less. Because nitrogen dioxide is a higher molecular mass. That's why its mass it's heavy. The rate of diffusion of nitrogen monoxide decreases as the temperature decreases. Suggest why using ideas about kinetic particle theory. Because the molecules, NO molecules, they move slower because the temperature, when temperature drops, their kinetic energy will be slowed, or it released, or it is lessened. Then we have PVC, which is polyvinyl chloride, and we have and polypropene are polymers made by reaction. Additional polymerization is happening here. Draw the structure of monomer we use here. So it's a simple C double bond, C with one carbon with a hydrogen, two hydrogens, and one carbon with one side chlorine and hydrogen, and one valency on both sides is vacant. So it is when you used it as a polymer. If it's just you show the monomer, then it is just you can simply say it is chloroethene. C double bond C, hydrogen with one carbon, two hydrogens with one carbon, and one hydrogen and chlorine on the other side. Then next is you have to draw the structure here. Polypropene is a polymer used to make a plastic food container, and here we have the structure. Name the toxic gas which released here. That is carbon monoxide, which releases a toxic gas here. Then state one other environmental challenge caused by the disposal of waste and environmental challenge in their explanation. It can landfills and the explanation is when you generate that landfills and you do all of that, they cause accumulation of plastics in oceans and it's not reactive. They are not chemically reactive. They don't dissolve in water. There we have the name one condensation polymer here. So it's nylon, protein, polyamide, polyester, PET. You can say anyone, and the peptide linkages here. You can see corresponding linkages here present.